Guess we're starting now, right?
It's a live show, man.
So this week on Quality Digest Live, why going green can bring in the green.
That's right. Plus, Dirk examines process signature analysis. That and more when we come back.
This episode of Quality Digest Live is sponsored by Hexagon Manufacturing Intelligence. Hexagon is shaping smart change by providing the confidence to increase production speed and productivity while enhancing product quality.
We on? Yeah? Anybody hear me? Are we recording yet? It's a subtle joke. Okay,
Yeah.
Welcome back to Quality Digest Live for February 24th, 2017. QDL is your weekly look at who and what is making the news in the world of quality. I'm Dirk Ducharme, Editor-in-Chief of Quality Digest.
It's one of those days. And I am Quality Digest publisher Mike Richmond. See, the D-I-R-K,
Yeah.
it has a significance. It means something. You know, this writing, it means you talk. But now I talk. Okay. Well, February, as we all know, is African American History Month, which offers us a chance to reflect on and appreciate the contributions made to our society by countless black politicians, artists, teachers, entrepreneurs, and athletes, not to mention millions of other more mundane folks from more mundane walks of life. Yesterday, we published an article from our good friends at NIST that celebrated a man whom actually I'd never heard of, but who lived a unique and far-ranging and really a fascinating life. The guy's name was Vernon Dantzler. And he was born in 1915. He was born in 1915 in a very different America, obviously, than the one of today. And he, as I said, had a really interesting life. The first thing you need to know about him, which I bonded with him on when I learned about him, was he was a star shortstop in the Negro Leagues in the 1940s.
Oh, wow. Okay.
Right? So great athlete, obviously. But it wasn't actually in athletics that he made his mark. It was in the realms of mathematics and computer programming that Dantzler is best remembered today. He earned a degree in mathematics from the renowned Tuskegee Institute, and then completed a graduate degree in the same field from American University. Now, after serving in the Second World War, Dantzler joined the forerunner of NIST, which at that point was known as the National Bureau of Standards. And by the early 1960s, he kind of found his way towards a fast-growing, fast-emerging field called computer programming, right? Now, Dantzler was one of the engineers who significantly contributed to NIST's OmniTab project, which was first released in 1966. OmniTab is now considered to be one of the first real spreadsheet programs, and Dantzler contributed several of the critical subroutines that made the program go. Features that we now take for granted in spreadsheets, such as automated statistical and data handling tasks, an extensive math engine, macros, graphs, and row and column-based formatting, all that originated within OmniTab more than 50 years ago. Dantzler, it's amazing, you know, I mean, you think about that in 1966.
We take it as
Take it for granted.
Take it for granted, yeah.
Popping stuff in Excel, but it all had to come from somewhere. Well, Dantzler retired from NIST in 1977, and he passed away at the age of 89 in 2004. But his legacy as an innovative and influential programmer lives on. So the next time you perform some simple function in Excel, you give a little appreciation to the fertile mind of Vernon Dantzler, who made that simplicity possible with some complex and insightful work a couple of generations ago in forming that spreadsheet routine. Really good stuff there. Nice picture of him right back there, you can see.
And it's funny, NIST is doing a lot of profiles on older people. And the people who have come up through NIST and their accomplishments have been really interesting. I mean, some of the stuff is just matter of fact, we had another one, it was a while ago, but one of the first women
female
programmers who was kind of behind the scenes, who nobody knew about, but everybody, I can't remember what her name was, everybody knew her husband.
We covered that on the story, this one too,
It's about the same time period too,
Same time period, the 50s and 60s, but NIST has got a rich history of amazing people that have worked for it, obviously, and hopefully they'll continue to bring us these little profiles, and we'll bring them to you.
All right. Well, for those of us who have kept up with metrology products, we have seen the fairly rapid transition of 3D metrology products from single sensor to multi-sensor products over the past decade or so, maybe 15 years, call it. And by multi-sensor, we mean the ability for a CMM or similar machine to use, let's say, a touch probe and an optical probe in a single measurement operation. And of course, as these products continue to mature, we see higher accuracies, better correlation between measurements taken by multiple sensors working together, and other advancements. Another advancement that we're going to talk about today is large field of view multi-sensory systems. And here with us via Skype today is Tom Groff of Optical Gauging Products, OGP, to talk about multi-sensory CMMs and large field of view CMMs in particular. Hi, Tom.
Hi, Dirk. How are you?
Pretty good. So, let's get right to it. What are the advantages of a multi-sensor approach to gathering metrology data?
Well, every sensor that does a measurement has strengths and weaknesses. So, you think about a video camera and a touch probe. They're good at certain things. So video cameras look good at looking at where surfaces meet and those edges. That's how a video camera makes measurements, is by extracting edges. Touch probe is good at getting into internal features and things that a video camera might not see. Where the video camera might be faster, the touch probe can get in and do things that are internal more. And then a laser is another very popular sensor on a multi-sensor machine. It's good at scanning over surfaces, getting topographical maps of surfaces, getting color maps and deviations of profile tolerances on surfaces. So if you have one sensor on a machine, you're limited in what you can do. If you have them all on the same machine, then you can do almost all of your measurements under one coordinate system, you have one learning curve, all these advantages, the throughput's better. So, combining all these sensors in one machine offers you speed, accuracy, ease of use, or throughput.
So Tom, our viewers out there obviously do a lot of different things within industry. So maybe you can help us out, give us a little bit of an example or examples of some typical applications for a large field of view multi-sensor metrology system, kind of like the OGP Fusion 400 that you guys have.
Yeah, so the Fusion combines this concept of multi-sensing with large field of view, which is another thing that's happening in the industry. You have a large field of view, allows you to do video measurements on a large area all at one time. Typically, video measurement systems would like to zoom up on a part to get it at a very high magnification to measure it. But thanks to new advances in optics, digital cameras, software, we can make those kinds of measurements with a large field of view where we see many features at once and still maintain micron level accuracies, which was always the limitation when you tried to get a large field of view and see lots of things at once. Your accuracy was limited. So that's kind of gone away. This Fusion machine is a combination of this large field of view capability with multi-sensing, and those two have never really been combined. So the large field of view gives you, increased throughput. It allows you to automatically identify parts, and the multi-sensor, like I said before, gives you full capability of measuring anything that you can possibly want to measure because it has all of those different sensors on it.
Well, I guess the main question you probably get asked a lot is, why should I buy such a system? I mean, what's the business case for something that you're talking about right here versus a traditional video measuring machine or a traditional CMM?
Yeah, it's a good question, and you can approach it two different ways. So we have a machine that is just a large field of view measuring machine. Some of you might be familiar with the Snap product by QVI. It is a large field of view machine. It's been excellently received. For those customers that have parts that are relatively small, they can put a part up there, hit a button, and get immediate measurements with the video camera. But it has limitations. It has limitations on the size of the part that it can see and measure. It has limitations in some 3D aspects. It's mostly 2D since it's video. And so they always ask, well, I want to do some other things with this. And with that system, you have to say no. And then on the other side, you have a multi-sensor system that's very capable, can measure anything, but as far as being able to automatically identify parts or doing automatic measurements for you without a program or doing very fast video measurements, you still have to move the stage on a typical multi-sensing system with high mag. So we get both questions. So the business case is we're trying to address what those customers have asked for, where that they want both in the same world. I want to be able to do automatic measurements without a program, but still on the same machine be able to solve my most complicated problems on my most complicated parts.
And Tom, I don't think, you may have said it, maybe I didn't hear it. When we're, in this case, when you're talking about the 400, when we say multi-sensor, are we talking vision and touch probe, or what are the sensors?
Yeah, all of the sensors that OGP offers on their traditional, measurement systems are available on the Fusion. So the video is the large field of view, but it also has a very high magnification. It's got 2 cameras on it, so I can do high mag stuff and low mag stuff if I need to. So those are kind of 2 sensors. You have the a laser, which is it's actually an interferometer that we would typically have on our Quest product, which is our high-end measuring machine. That laser we brought into this system. It's the most capable laser we have. And then scanning probe, touch probe, those are typical sensors that people like. And then we have micro probes too. So we have a small little feather probe that can get down to about 100 micron stylus. We have a rainbow probe, which is a white light sensor. Any of these sensors can be added to the system, and it depends on the application and what the customer might want, whether they want one or all or some subset of them, and the system's configurable that way.
Okay. Well, we're doing a webinar. Actually, you and I, we're hosting. Quality Digest is hosting, and you're going to be the brains. That's going to be on March 2nd. What are people going to see when they attend that event? And then we have it right there. Just let everybody know that's Thursday, March 2nd, 2 p.m. Eastern, 11 a.m. Pacific. What are they going to see at that event?
Yeah, I'm looking forward to the webinar. It's a good opportunity for us to launch this product and let people know what its capabilities are. We're going to take a deep dive into what kind of applications you can solve, how it does automatic measurements without any prior knowledge, how the sensors are incorporated, and then some of the output capabilities that you can get with it. We're going to look into the Zone 3 multi-sensing metrology software that runs the machine. So we'll take a deep dive into all those different aspects and hopefully give everybody a good sense of how this is distinguished over a traditional OGP machine, a traditional CMM machine, whatever, and be able to see the differentiation and also some advantages that might be over some of those other products.
Okay, terrific. Well, Tom, thanks for joining us this morning. Again, that webinar is going to be the Fusion Metrology System, coming up next Thursday, March 2nd at 2 p.m. Eastern, 11 a.m. Pacific. There is a link to sign up for that webinar right underneath the player page. You can go out there, click that, and that'll take you out there. Tom, thanks a lot.
Thank you.
Thanks, Tom. See you next week.
Yep.
Yeah, it's gonna be a good one. Tom's a great presenter, and we have a really interesting video clip with that too that we captured, that Chris Smith captured for us. So tune in for that one next Thursday and register for it. It's gonna be a good webinar. All right, well, sustainability. That's the subject of our next article. It's a topic that, like a lot of other things these days, has become somewhat politicized, and maybe some of us, me, have kind of been responsible for that a little bit. But that's okay. When you step back and you look at it without any preconceived notions, which we all should really try to do when we talk about these things, I think you'll see that the idea of sustainable business practice really just makes good sense. I mean, and that's the take on it presented by author Andrew Sloan in his article, Why Going Green Can Bring in the Green, $, $, love that, which appeared in Tuesday's issue of Quality Digest Daily. You saw it right there. Sloan points out that many people think that everyone falls into 2 camps when it comes to sustainability, either tree hugger or planet plunderer. I like that. I don't like the second part so much, but I mean, it's easy to see this idea, the idea of sustainability in blacks and whites like that. I mean, I think many of us probably tend to do that. But Sloan believes that there are really big gray areas in which many, if not most of us, can agree when it comes to sustainability. Primary among these is the pursuit of higher profit through greater efficiency. I mean, that just makes good sense. Being sustainable in its most basic form simply means that businesses maximize the resources that they use. I mean, smart business people from the days of Henry Ford and earlier, recognize that fact. Yeah. I mean, it was a pretty clear fact. Efficiently using resources means less waste, which is inherently good for the organization using those resources, and it's a happy coincidence. It's also really good for the planet, right? I mean, you use less stuff, to create what you need to do, that you need to sell. And you're going to make more money because you're going to spend less on the goods. You're going to have less waste, and the planet's going to enjoy that too. So
exactly. They should go hand in hand.
It should go hand in hand. It's really not politicized. It's a pretty straightforward business case for that. But the question is, how is that best achieved? Well, it's actually pretty simple. It's achieved through better design of things like physical structures, of work processes, and of business goals and aspirations themselves. It all comes back to design, engineering your processes, your businesses, your structures to take sustainability into account. It's not really that hard when you do it upstream far enough in your process. And as an example, Sloan points out a pair of companies that really have transformed their ways of doing business through a relentless focus on sustainability achieved through continuous improvement. There's that phrase we always like, continuous improvement, as well as efficiency. The first that he references here is a company by the name of Interface, and they're carpet manufacturer.
You know this
company,
one, right?
Oh yeah,
yeah, interesting.
They're a carpet manufacturer that embarked on a journey towards 100% sustainability more than 20 years ago, 1993.
Yeah, ahead of their time.
At that time, nobody really was thinking very much about these issues. Well, a key facet of their undertaking was the engagement of their employees, wherever you heard that before, right? I mean, the Toyota production system, right? Respect for people. The Interface CEO, Ray Anderson, and his executive team challenged everyone in the company to look at reducing waste in every single facet of their production flow, from the sourcing of materials to installation to removal when the carpets had reached the end of their useful life. Not surprisingly, profits soared as waste was eliminated and customer satisfaction increased too. I mean, that's that win-win-win. I mean, it's so easy to see when you see it designed properly in. I mean, everybody in the company was looking for waste and trying to eliminate it. As a consequence, their profit went up and then customer satisfaction went up too. So that's a really good example. And there's another good example he uses too. A company by the name of Prologis, which owns and operates industrial warehouses. This company's vice president, Matt Singleton, talked about how their installation of solar panels on the roofs of their numerous buildings turned into a for-profit activity. He used that exact term. They turned an unused opportunity, all this empty roofs, right? I mean, they have all these warehouses. They turn that into a real asset. Prologis now has the second largest installed solar capacity in the United States.
Wow.
Amazing. And they sell, as you would imagine, they sell a lot of power into the grid. I mean, they turned it into a for-profit activity from basically just a wasted resource. And they said, hey, we can use this.
Got all this roof space.
Why not? It's good for the planet too. Again, common theme. And the common theme here is something that might be termed intentional sustainability. And that's really sustainability with a sharply focused end goal in mind. I mean, whether it be to cut the manufacturing costs of carpets or create a profitable asset out of empty roof space or really anything. I mean, there's opportunities everywhere to be more efficient, to save money, and to reduce waste. And as a consequence, to reduce the strain on the planet's resources as well. I mean, we're doing that here in our little way. Remember, we put those fans up because we took advantage of the opportunity to suck the hot air down during the cold months and bring the cool air
really
up.
Tall ceilings we got in here.
We got the tall ceilings. So I mean, little things like that, were just a consequence of people thinking about it and saying, well, what are some ways we can use the resources that are here to our advantage, to lower energy costs and use less energy, which is a good thing for the planet too. I mean, it's really not, again, that black and white. You're not either a tree hugger or a planet destroyer, right? I mean,
planet plunderer.
Planet plunderer. I mean, you really can do both. I mean, you don't have to do either. You can really take advantage of the opportunities that you have and make it good for the planet and good for your company too.
By the way, if you want to see there's several videos out that highlight the work that Interface and Anderson have done.
Including one in that article.
Including one in that article. There's actually a full-length one that's, I wish I could remember the name of that. I wish I'd looked it up for you. It's really a fascinating company.
Really, really interesting company. So check that article out.
Yeah. All right. Well, anybody who has ever worked in manufacturing will tell you that in-process testing or verification is really much better than end-of-line testing. I mean, again, it's kind of a common sense thing. Why push a product all the way down an assembly line to be tested if it is already a problem that will cause it to fail that occurred early on in the process?
I think the phrase is you can't inspect quality into a product.
You can't inspect quality into a product, that's right. And yet, that's how a lot of assembly lines work. It gets to the end, they test it, it failed. Yeah. So in-process testing is really a much better way to go. I mean, you're going to find the problem early, and then you're going to deal with it. And in theory, this sounds good, right? But for complex assembly processes, let's say automotive manufacturing, in-process testing can be difficult because at any particular stage of the process, there's just so many parameters that have to be looked at, and often those parameters interact with each other. So how do you do this? Well, there is something called process signature analysis. It's essentially a single test output that reflects dozens of inputs. So one output that you can look at that reflects dozens of inputs. So you can read a little bit about process signature analysis in the article, The Birth of In-Process Testing by Nathan Schaaf. But actually here, via Skype right now to explain process signature analysis live, is Richard Brine of Sciemetric. Hi, Richard.
Hi, Dirk. How you doing?
Oh, pretty good. So not everybody has heard of process signature analysis. Can you just describe to us what it is and how it works?
Absolutely. If you go to slide 1, we might be able to, that's great, thank you. Really what we're dealing with is a repeatable process. This is how we've been applying it a lot. For example, discrete manufacturing or an assembly press. We need sensors to measure physical attributes such as force, distance, pressure, or current. We then can digitize these signals with high resolution, and we can form a signature or a waveform from which we can gather insights and information about that process. We can then analyze the waveform, we can make decisions, and we can then serialize and store the data for future reference or comparison or reanalysis. So just like a beating heart, every regulated process has a repeatable signature or digital fingerprint that can be used for optimal quality and control. On the next slide, we can see and dive a little bit deeper into an example of an assembly press. If we use a load cell, we can capture the force, an LVDT, a linear variable differential transformer kind of sensor. We can digitize the distance as the ram forces the pin into place. This creates a force versus time and a distance versus time curve. We can combine these and create a force versus distance waveform or signature, as shown in the image 3 on the right. On the next slide, we can start tearing this curve into little bits and pieces, and we can see the unique attributes of the signature or the shape of the waveform and how it corresponds to information about that process. So, for example, in the first stage, if the pin isn't perfectly aligned, there can be a rise in the force as that pin hits the part opening and then moves into it. The value of this force can be used to infer the quality of the machinery, indicating poor setup or wear over time. In the second stage, we can see the pin is progressively being pushed into the opening. And as that happens, the force increases due to greater surface area and contact. And the value of that force can really tell us a lot about the tolerance of the parts. For example, if there's a really high force, the parts are just too tight. If it's too low, the parts will fall apart. At the end of stage 2, we can see we can call a point called the max insertion force, which is that little triangle. This can be used to indicate as an indicator of the quality of that press operation. As a third stage, where the pin bottoms out, here we can see an increase in the force because it's not going to go any further, and very little distances will happen. And we can see that steep rise in the force versus distance. This can be an indicator of the stiffness of the press machinery and show wear over time, or allow us to compare machine to machine. So we can see a lot of insight can be gathered from any process from the signature waveform. On the next slide, we can see what we can do with that signature. So we've digitized it, which is great. And now that we know some insight about what the shape of the curve means to us and how it reflects the process, we can perform some analysis. In that first image at the top left, we have signatures from many press operations overlaid together. This is an important step as we can see how the process varies from part to part, and that any measurements we make on the waveform will be consistent. Knowing that max insertion force reflects the quality of the press fit, we need to extract this information from the waveform. In order to do this, we can take a maximum within a specific window of the press stroke as shown in that green box. The red cross indicates the maximum of one of those signatures. So image 2 now shows a plot of that maximum insertion force for all those press operations. This allows us to see if there are any trends in the data perhaps due to time, operator, shift, different model types. The histogram provides insight into the distribution of that data. For example, is it a normal distribution, like a bell curve, or is it bimodal with 2 humps into it? That may give us insight into what's happening in that process. So we can then calculate statistics on that trend, as shown in image 3, that can help us to understand if our process is in control. If we can actually plot some of those, shown by the dotted lines in the graph of figure 2 and 4, which are plus and minus 3 sigma lines, for example. So now that we know all this, we can easily set reliable pass and fail limits on that particular feature, as shown in image 4 with the red lines, which we normally call specification limits. So we do all this analyzing on stored process signatures without really having to rerun additional parts. By the end of this exercise, we can have complete confidence that the analysis and limits we set are optimized for our process. If we go to the next slide, we can see, and it always is the case, that a picture is worth 1,000 words, and really a signature is just like a picture. So we can find, and from that picture, we can see insights that we perhaps didn't realize before, and they can surprise us actually. So for example, here we see spikes in the press portion of the waveform that are not normally present. After investigating these parts, we found that the pin chattered or rocked back and forth as it was inserted, creating these spikes in the waveform and also creating that bad part. So this required adding a new waveform analysis. Let's say that we didn't do any analysis in that zone, so these parts kind of left the factory, let's say, and we didn't have any of that analysis done. So in order to capture this, we have to add a new feature check in that area. So, but if we have all this historical data and it's serialized, we can run through that data with that new window, that new analysis, and we can identify the parts with the similar signatures, and then we can easily do a selective recall. And of course, any future product will be contained. In one more slide, in slide 7, there's another benefit to signature analysis where we can optimize the cycle time. As we all know, cycle time is very precious, and optimizing it is very valuable. Time is money. So using process signatures is one of the best ways to perform this optimization. Here we have a leak test example where the signature is flow versus time. The curve in image 1 is of several flow tests overlaid. Using the historical reprocessing of these signatures, we can add a new analysis for various shorter cycle times, as shown by the green boxes in that figure 1. We can plot the resulting statistics, and see the effect on that gauge R&R, or the repeatability, basically, of the test versus cycle as we reduce that cycle time. And that's shown in figure 2. So here we can realize that we can obtain roughly the same repeatability with a cycle time that's 20 seconds shorter. That's certainly good news if you want to increase productivity. I think on the last slide, maybe just one more, and then we'll kind of open for discussion. So ideally, every process would be captured from the entire production line, resulting in a true digital birth history record for every part. All this data needs to be organized in ways that are understandable, for example, by line layout, with sections, stations, operations, or perhaps by similar stations, for example, all weld stations or all torque down stations. Records would ideally be stored by serial number, that's the point 2, or by batch number if not serialized, and the full signature data would be stored for each process. This allows ultimate troubleshooting of the entire line. For example, if a leak test is starting to fail, we can now investigate the data for any upstream process that could affect the leak. Perhaps there's an ultrasonic welder or a machining station that we can identify is the issue, because it may perhaps the bit was wearing out and created grooves in the machine surface. And we can detect that if we have those signatures, for example, vibration on the spindle of that machining process. So that kind of sums up a bit of what process signature is and how it can help you.
Okay, I got as you were going through that, a couple things came to mind. First of all, this can be done real time, right? I mean, what the operator sees at a particular station is one of those curves that you're talking about. Do I have that right?
Yes, exactly. That's exactly right. Every station, so we call it real time, in the sense that we gather the data right where the process is happening. So you're pressing the two parts together, you're gathering all that data, and data analysis happens the instant that the data collection is complete. And then the pass-fail result is passed to the PLC, or program logic controller, and then from that the PLC can take care of, okay, this is a good part, this is a bad part, sorting them out, making it all go to the right place. Yeah. So that instantaneously there is, as you said, yes, that the analysis is done right away.
So let's talk about the pass-go real quick here, because I didn't catch that bit. So this curve shows up, so you're able to show the operator or automatically create some bounds over some part of that curve so that they know that that curve is out of whack, is not the signature that you're expecting, that's something that visually they can see?
So yes, there are kind of two ways that it can happen. One way is that we have, obviously there's the feature that was extracted, say the maximum insertion force. And for example, say there'd be limits on that, like 2,000 newtons down to 1,000 newtons. Anything outside of that band, you would alarm, and there would be a red indicator saying, hey, that particular feature failed. But a very good help and aid is to have a normal curve shown, and then a band of acceptable curves shown, so that in case there's actually new errors that happen, that you're not maybe doing a little feature extraction in that area, the operator can easily see, hey, wait a minute, that curve is out of bounds in a new area. That's very helpful, and the operators can easily get insight and can train and tell lots of the process engineers what's going on, because they say that, you know what, when I get this issue, there's actually a new little bump over here. And that is great, because you can use that information to create a new feature, a new test feature extraction, and that can now make sure you've contained those issues as well.
Okay, and the last question here, and I think this is maybe somewhat related to what you just said. Besides pass-fail at a particular point, how can signature analysis be used to, let's say, troubleshoot a problem? For instance, let's say, as you've shown, you're combining, force and distance or force and time into a single signature. How do you know if a bad signature is due to the wrong force or the wrong distance? And how do you now dig down into it once you see something is wrong?
Right. So that goes back a little bit to having an insight into what's happening in the process. So if we understand that how the features of the curve, the shape of the curve, reflects the physical world. For example, we talked about that alignment force, the little peak at the beginning. That's really helpful. If we start seeing that increase and get higher and higher and higher, what can happen is we say, listen, we've got a nominal curve, as you mentioned before. We can see this is now deviating from that nominal curve. And we can say, great, let's go and figure what that is out. If we didn't know that that first peak was alignment, we could do some investigating and find out what's happening. And eventually we'll discover, okay, it has to do with the beginning. It has to do within the time that the part is just contacting the other part. And what will happen is we may have good stations that are passing and not having that first part, and bad stations that are, and we can compare them. And then what will happen is when we investigate that area, we'll be able to go down to that machine and find that it's now uncalibrated, or maybe it's worn out, and that misalignment is happening, getting worse and worse. So definitely signature analysis allows you to have that insight. It's directly related to the process, and the more we understand how the shape of that curve reflects the process, the more we can then use that information and help us with our troubleshooting and root cause analysis.
Okay, well, Richard Brine, Chief Technology Officer for Sciemetric. Interesting technology. It's been a long time since I've come across signature analysis. I've used it in a much different setting. I've never seen process signature analysis. That's really interesting stuff. So thanks for joining us this morning.
Great, thanks for having me.
And if you guys have any questions about process signature analysis, there is a link out to Sciemetric on the player page underneath there, right next to Richard Brine's name there, and you can click on that and go out to Sciemetric and read about it.
Thanks, Richard.
All right.
All right, well, that's the end of our show. But before we go, of course, we want to thank our sponsor. Hexagon Manufacturing Intelligence is proud to announce that their new laser tracker scanning technology is available for the portable Roamer Absolute Arm with integrated scanner, their SI series. The new RS4 scanner offers completely new optics and electronics, delivering a major performance leap with a scan rate nearly 60% faster than the previous model. The new RS4 scanner introduces an ultra-wide laser line, nearly double the width of its predecessor, which translates to larger surface coverage and faster data collection. With a higher point resolution, Roamer users can obtain greater point cloud detail in significantly less time during a scanning session. The new Roamer Absolute Arm SI featuring the new RS4 scanner is available to order via local Hexagon Manufacturing Intelligence sales offices and dealers. So for more information, click on the banner ad just below or just to the right of this video player screen.
That's right.
That's right.
And that is the end of today's show.
That's right.
Just a reminder, everybody, OGP webinar coming up. Fusion Metrology System this coming Thursday, March 2nd at 2 p.m. Eastern, 11 a.m. Pacific. The webinar will be presented of Tom Groff of OGP, who I talked to earlier in the show, and will include some great video clips of OGP's Fusion 400 large field of view multi-sensor measurement system shot by our own Chris Smith at the MD&M West event in Anaheim earlier this month. Our webinars have been killing it lately.
Yeah, nice work, man. You've been doing a good job on those. We got some great webinars. So keep your eye on your inbox for details about how you can register to check it out. Well, hey, thank you all for joining us in today's show. Check out the webinar next week. Thanks, Tom Groff, and thanks, Richard Brine, for joining us today. And you all have a great weekend, and we'll see you next week.
So long.
Bye.